Okay, so as you can see, we have a new audience. They've been playing with Legos. That was from my statistics class. They don't really have to play with Legos here, but I thought that it would keep them more entertained. Okay, so exponential functions. This is probably the topic that is most applicable right now. I'm sure if any of you are watching the news, you've watched exponential, you've seen exponential graphs everywhere, so you're familiar with that. Exponential functions also have a lot to do with the economy. So we're going to first just really quickly look at what an exponential function is, what it looks like, and then we're going to talk about the applications, and then we're actually going to do some of these applications. So So first of all, an exponential function looks like this. It's f of x is equal to b to the x. So we kind of, actually I'm going to say ab to the x. That did not come out well. So it's ab to the x. Notice here the x is in the exponent. This is what makes it exponential. Your variable is in the exponent. So unlike our polynomial functions where our variable is 2 or 3, here our variable is in the exponent. That's the difference between exponential and polynomial. Exponential function, our variable is the exponent. If your variable is anywhere else, it's not exponential. Okay, so we kind of talked about this already, but the b is the base. The a here is actually the y-intercept. So this is not hard to see. If x were equal to 0, now we know from our discussion of exponential properties that anything to the 0 is 1, right? So a times 1 is just a. So it makes sense if we plug in 0. So f of 0 is a times b to the 0, which is just equal to a times 1, which is just equal to a. So that's why we say that a is our y-intercept, and the b we call the base, okay? The b is not equal to 0. If it were equal to 0, then we would have 0 to the x, and 0 to the x is 0, so this whole thing would be 0. It can't be exponential. It would just be a point, f of x equals 0, a line at y equals 0. And b is greater than 0. If b were negative, the problem is that if this exponent were odd, then you would get a function that sort of looks like this. Get these dots. Okay, and we wouldn't call this exponential. At least we're not going to discuss it. I didn't leave enough room here. I'm rewriting the same thing. Not exponential. Okay. From here, you can kind of gather that an exponential graph, a b to the x, the general shape of that graph. And again, if you've been watching the news or reading the paper, I am sure that you have seen this a lot. So the general shape of an exponential is like this. And we also talked about the domain and the range. Okay, the domain is all real numbers. This just keeps going up. This is actually terrible. I'm gonna redo this. It looks terrible. This is a little better. Still doesn't look great, but you get the idea. This is the general shape of an exponential graph. The last thing is that your x is your exponent. And the only requirement of x is that it's real. So we were talking about domain and of other graphs, and we touched upon this. You may not remember, but we did touch upon this in class when we were talking about domain and range of functions. The domain of this graph is all real numbers. You can see that the x values, okay, if x were negative over here, like negative 100, we would still have a value. If x were positive 100, we would still have a value. It'd just be way off the screen, okay? So our domain is negative infinity to infinity. And our range is only 0 to infinity. Okay, we approach 0, we never actually reach 0. There is no power that we can raise b to that will give us a 0. Okay, so we get very, very close. If b is a fraction like 1/2 to a really high power is a very, very small number, but it's not 0. We never actually reach 0. Okay. And the only time that we would reach 0 is if b is equal to 0, and we already said that that wouldn't be an exponential function. That would just be a line at the x-axis. Okay. Okay. So let's talk a little bit about exponential functions. I want you to think about, I'm going to ask you a question and I want you to think about it for a moment. Okay. Suppose that you have two choices. Your first choice is you can get $100 million today. $100 million. Your second choice is you put a penny on the first square of an 8x8 checkerboard or chessboard. And every day you double it and you put the new amount on the next square. So every day you double what was on the previous square. And you put that on the next square. Now you don't get to keep everything on the chessboard. You just keep going until the 64th day, right? It's an 8x8 chessboard. you get to keep what's on the 64th square, just what's on the 64th square. So just take a second, even pause the video for a second and think about it and say, which of these choices would you take? Okay, would you take the 100 million today, which is a lot of money? I mean, 100 million is a lot. We could even say 100,000, doesn't matter, it's still a lot of money. And you take that today, or you put a penny on the first square of a chessboard. On the second square, you have 2 pennies, so 2 cents. On the third square, you have 4 cents. On the fourth square, now you have 8 cents, and so forth. And you get to the 64th day, and you're allowed to take whatever money is on the 64th square. So think about it. Which one would you take? The $100,000 or $100 million? Or what's on the 64th square? You're thinking. Okay. So let's think about what this means, okay? We're doubling every day, which means that our base is 2, where we keep multiplying by 2 over and over and over again. How many times are we multiplying by 2? 64 times. Let's see what 2 to the 64 is. Okay, now look at how huge this is. But let's be honest, we started off with 1 cent, not $1. So we have to put in a decimal point after the 16. So we have, this is 100 million for the first. For the second, we have 1, 8, 4, 4, 6, 7, 4, 4, 0, 7, 3, 7, 0, 9, 5, 5, 1, 6, 1, 6. And there's got to be a decimal point over here because we're starting off with 1 cent, not $1. So let's see how much that is. So this, if we mark off every 3, this is 100,000s here. The 7 means 7 million. Okay, now we have 737 million, 440 billion, 467 trillion. This is quadrillion amount of money, quadrillion dollars. We started off with a single cent, and now we have 184 quadrillion dollars, almost 184 and a half quadrillion dollars. That is a lot of money. Look at this exponential growth. Look at how fast it is. Now you can see why when you look at the news now, this idea of the spread of the coronavirus is so scary because you have things doubling in less than a week. I mean, on last Friday, we hit 80,000 people who were infected with the coronavirus. Now I think we're up to 250,000. We have more than tripled in a single week. Now imagine if we kept doing that in a single week, we're tripling. Well, how much is that when we, after a few weeks? So let's actually calculate that so that you can, I don't want you to get scared because eventually this is going to stop, okay? We are going to reach a peak. So a lot of you are looking at graphs where we reach a peak, an apex, and then all of a sudden it starts going down. This is exponential growth, but unlike this exponential graph, we will turn around, okay? But let's just see what happens. So if we start off with the 80,000, okay, from last Friday, okay, and we know that we're tripling every week, and again, this will eventually slow down, so don't panic. And we want to know, okay, well, how much is this going to be after 6 weeks? And we don't, let's not even think about after 6 weeks. Let's think about after 2 weeks, because we expect the apex to be in 7 to 21 days. Okay, that's what most of the models are looking at. So let's just square this. Okay, well, if we square this, now we have 720,000. If we do the same thing and we say, okay, let's say that we don't actually hit that apex for 4 weeks. Well, now we have 6 million, 6.5 million. So you can see why we're hoping that that apex comes earlier. Because if it's tripling every week, what this is telling us is if the apex doesn't come earlier, then we're going to have 6 million. And that's not what is expected here. Okay, that is not what is expected. We don't expect that much. Okay, and it tripled this week. It may take a little bit less time to triple. So this isn't a perfect model because we're changing things as we go, right? We're practicing this social distancing slowly. Every state in the country is practicing this idea of social distancing to try and control the spread of the virus. But you can see if there is no social distancing, if we just let it grow without doing anything to try and stop it, you can see why that number is scary and why people are saying, no, you have to change the variable. You have to do something because exponential growth happens so quickly. In 2 weeks, it would be 720,000. Okay. In 1 week, it's 250,000. But in 2 weeks, it's 720,000. And in 4 weeks, it's over 6 million. And that tripling, by the way, part of that is because we haven't practiced social distancing throughout the country. So now that a lot more states have started doing it in the last week, and it will start to slow down. So hopefully next Friday, it's not going to be, you're not going to see that it's tripled. You're not going to see this 720,000. Okay. But this just gives you some idea as to what's going on and what the different models are and why we call it exponential growth. Okay. Okay. So let's talk about the applications of exponential growth. And this is also applicable because of the economy, and we're all a little bit concerned about the economy and whether or not we'll have jobs, whether or not we'll be able to afford things that we used to be able to afford, whether or not companies will stay open, things like this. These are common worries. And let's just talk about how things work in the economy. Okay, so just a quick discussion. And we're going to focus mainly on banking because that's where it applies. So some of this will apply, most of this will apply directly to you, and some of it will sort of see in the larger scheme of things. Okay, so exponential functions have huge applications for us. It's one of the only areas of math that we do actually see in our daily lives on a regular basis. Okay, so the coronavirus is one example. This is another example, the financial part of it. So let's talk about banks. So we have a few things going on here. When we go into a bank and we put our money in a bank, we have certain types of accounts, okay? So we're specifically talking about banks here. So we have lots and lots of different accounts. They're going to offer you lots of different things, but they basically fall under 4 different categories. We have checking accounts, which if you have your money in a bank, you probably have a checking account. We have savings accounts. We have something, I don't know if it's still called a money market, but it's essentially a money market account. And then we have something called a certificate of deposit. Or it's typically referred to as a CD. And essentially the difference between these accounts These are the biggest differences. So let's talk about that. So in order to talk about that, we should first talk about how banks make their money. So some of you may already know this. And there are lots of different ways that they do this. Loans. Typical loans might be for a car, for a mortgage. A car would be a much smaller loan. A mortgage is a much bigger loan. A small business loan. Okay, we'll get back to loans in a minute. Another way is just by basic fees. So we have something called overdraft fees. So an overdraft fee is essentially you go in and you write a check to somebody, okay? And let's say that you have $100 in your account, but you write a check for $200. Now, what the bank will do is it'll say, okay, we'll let that person cash that check, okay? Sometimes it can be really embarrassing if somebody tries to cash a check and then they can't. So if you have $100 in your account, they might say, okay, we'll let the person who you gave the $200 check to deposit the check. But you're going to be charged a fee because essentially the bank is paying $100 and it's $100 that you don't have. So they might charge you a $50 fee or something for something like that. You have ATM fees, right? So if you take money out, if you have money in, let's say, Chase Bank, but you use an ATM from TD Bank, you're going to be charged, I think it's like a $3 or $3.50 fee every time you take out money from an ATM at a different bank. It might be minimum balance fees. So in a lot of I'm going to put etc. here too. For example, you might need in an account to have at least $100. And if you take out money and you fall below $100, they'll charge you a certain fee every month. Sometimes it can be as much as $10. Sometimes they'll charge you a fee just because you haven't used your money. Okay, so if your bank account has went untouched for a year, they'll start charging you. Okay, and then one of the other ways that they make money is they invest it in the stock market. And we're going to talk about this a little bit more because obviously the stock market has taken a big hit. So just really quickly going back to loans for a second. When you go into a bank and you ask for a loan, they're looking for certain things, okay? What they're looking for is they're looking for a steady income. This is how they determine if they're going to give you the loan. They want you to have a steady income because they want to know that you can pay the loan back, okay? If you don't have steady income, then they don't know that every month you're going to be able to make your payments and you're considered an unreliable person then. So steady income. Then they're looking at your credit score. So if you have a credit card, you have a credit score. If you have a loan, like a student loan, you have a credit score, okay? Your credit score is kind of like a measure of your reliability. Do you pay your bills on time? If you pay your bills on time, your credit score goes up, okay? And that goes for loans too. Are you doing your loan payments on time? Are you paying your full loan payment? If you're doing that, your credit goes up. Okay, so these are things that they look at. So, for example, let's say that you have student loans. Now, if you pay your loans very quickly, so let's say that you pay your loans over 2 years, even though you have 20 years to pay your loan, you actually have a lower credit score. And the reason for that is that there hasn't been enough time for anybody to establish reliability. They've said, okay, you paid your bills over 2 years, but that's not enough to say that you're reliable. If instead you're saying, okay, you consistently paid your bills over 15 years, that makes you so much more reliable. If you only have one credit card, that can be actually a mark against you, because if you're paying one credit card bill every month on time, that's great. But if you're paying 2 credit card bills on time every month, then that's going to give you a higher credit score. So all of this makes you more reliable. Now, you shouldn't have lots and lots of credit cards, but you probably should have at least 2. That will increase your credit score. So all of this is about reliability. That's what the steady income is. That's what the credit score is. Credit score has shown a history of reliability. The steady income is saying, okay, well, that says that you have a future of reliability. The last thing that they look at is assets. Assets are things that you own. Okay. The reason that they look at assets, so all of these things are things that the bank uses to determine if you get a loan. The reason why they look at assets is because that's okay. Let's say that you had a steady income and you had a good credit score, but something happens and you can't pay your loan anymore. Okay. Well, what they do is they say, hey, you're required to pay your loan. You can't just say, I can't pay it. So if you don't pay it, they come after you. They start taking away your assets. If you have a car, they take your car and they say, okay, this car is worth $10,000. $10,000 goes to your loan. So they possess it. If you have a house, they take your house. They take everything that you own until your loan is paid back. Now, let's say that you don't have a lot of assets. They may not give you a loan, but if you go and you say, okay, I have a co-signer, I have somebody who will co-sign the loan with me, or I have a guarantor, okay? They say, okay, we'll give you the loan then, because you have a good steady income, you have a good credit score, and your guarantor or your co-signer has assets. Now what that means is if you don't pay the loan, they go after the person who co-signed the loan with you and they take their assets away. So somebody who's willing to co-sign a loan or willing to be your guarantor has to be very trustworthy of you, because they know that if you don't pay the loan, then they're the ones responsible. Okay, so this could be a little dangerous. So for example, I had a student who was buying a car once and she asked me to be a guarantor. Don't do that. Okay, don't ever do that, because you want it to be somebody who you absolutely know is very, very dependable. Okay, and a student is not good enough. You want it to be somebody who you know very, 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 very well. Okay. So this is how banks make their money. And the reason that they make so much money on the loans is because they charge you interest. So it might be, for example, on a student loan, interest could typically range anywhere from 3% in an economy that's, average economy. It could range from 3% to, let's say, if it's a bad economy, it could be 8%. Okay, and 8% is large. That means that every month you have to pay 8% on your loan. So for a long time, all you're doing is essentially paying interest when you pay off your loan. Okay. You can do something called consolidating your loans. What that means is that you have a fixed interest rate, and this is something that when you get out of school, if you have loans, you're going to look into. The reason for consolidating is, let's say that you graduate when the economy is great, okay? So when you graduate, if you graduate when the economy is great, the interest is going to be very low. And if the interest is low, you want to consolidate, because then you have a fixed interest. That interest is not going to change, even if they raise the interest rates and it goes up to, let's say, 8% or 10%, okay? If you graduate and the interest rate is at 8%, do not consolidate. Because what that means is if the interest rate goes down, you're still stuck paying 8%, okay? So if the interest rates are high, you don't want to consolidate. If the interest rates are low, you do, because then even if the interest rates go up, you still get the low interest rate, okay? So why is it important how banks make their money? The question is, for the loans, where do they get their money? Where do they get this money to give to people to pay for a house or to pay for a car or to pay for their small business? They get this money from you, from your checking accounts, from your savings accounts, your money market account, your certificate of deposit account, okay? So that's how they get their money. So here's the difference between the accounts. When you have a checking account, you have almost complete access, constant access to it. You could go to an ATM in the morning, take out $40 from your account, and then go to an ATM in the evening and take out another $40. You have constant access. So your money has to be available to you at all times. Now, we all have a checking account because we all have bills to pay on a regular basis, and we all need money on a regular basis to pay for food or clothing or whatever it is. We need constant access to our money. So that's typically going to be a checking account. Now, because you have constant access, the bank can't loan it out to people. So your reward for keeping it in the account longer is interest. And you're going to get very small interest rates. And interest is money that you get just by having your money sit in the bank. Okay, so you might get 1% interest, you might get 0.5% interest, and all of that is your money sits there. You don't have to do anything. It's just money that's given to you. Okay, so for a checking account, you need constant access. The bank is not going to reward you for constant access. They can't do anything with your money. They can't make money off of your money. So you're going to have very, very low interest rates, if any at all. Okay. For a savings account, you have a little bit less access. So it might be that you can withdraw money from your account maybe 7 times a month. Okay. Well, that means that you still need a lot of access. So you'll get some interest. It's just that you won't get that much, because if you go into the bank, you're saying, I need to have my money available to me. And because of that, your interest rates are going to be a little bit lower. Because again, the bank can sort of give out that money to other people for loans, but they still need to make sure that it's on hand to give to you in case you want it, because it is your money. So you'll get more interest, but it's still not that much. Okay, typical interest now for a savings account might be 0.5%, maybe 1%, maybe 1.25%, although I think that that's pretty high right now. A money market account is maybe you have access once a month. Okay, so you have less access, but because you have less access, that means that you have more interest. If you withdraw, you go to the bank and you withdraw money more times than you're allowed, you actually get charged a big fee, okay? Because you're saying that you need your money when you already promised that you didn't. Certificate of deposit is no access, okay? So a checking account is constant access. And low or no interest. This is maybe 7 times per month. interest. And the more money you have in the account, the more interest you'll get. This is very little access. So maybe once a month. And it means that you have a higher amount of interest. So if for a savings account it's 1%, for a money market it might be 1.5%, which is very high. Actually, nowadays it's very high. A CD is no interest. No access. But very high interest. And the reason why it's very high interest is that the bank can loan it out and they know. So a CD can range in amount of time. You could say, I don't need access to my money for 3 months, 6 months, 2 years, 10 years. The more time that you sign up for the CD, the higher the interest. Because if you're saying, I don't need any access to my money for 10 years, then they're going to say, okay, that's great. That gives us the opportunity to loan it out. And if that's giving us the opportunity to loan it out or invest it, then we're getting a lot of money. And that's good for us. So our reward to you is more interest. Okay? Okay. Let's talk about some of this other stuff. So one of the other ways that the bank makes their money is by investing it in the stock market. So you could see why this could be a negative thing right now, right? If the stock market crashes, what happens? The banks make bad investments, or they make investments where the stock market crashes and it becomes a problem. Well, if that's the case, okay, then the bank loses money. And if the bank loses money, then how does it pay you your money back? Okay, so during the Great Depression, this was a serious problem because people got scared. They felt the banks were closing and they were going to lose their money. Okay, the banks made investments. The banks were losing money. If the banks lose money, they close. You lose your money. So you go and you run to the bank and you take out money, all of your money from the bank. And how the bank closes. So it's like the self-fulfilling prophecy where you're worried that the bank will close. So you actually cause it to close. So in order to prevent this from happening, FDR, he was president during the Great Depression. And he came up with he passed something called the New Deal. And this came up with a lot of programs to help bring us out of the Depression. And one of the products of the New Deal was something called making the banks FDIC insured. And what that means is if the bank closes, what you have in your account is still guaranteed to you. You don't have to worry that the bank closed, so you lost your money. Okay? This guarantees you get, I think it's up to $500,000 now. So obviously, if you only have $1,000 in your account, you're only going to get $1,000 back. But if you have $500,000, you're going to get $500,000 back. If you have $6,000, you only get $500,000 back. This is very, very helpful to us because think about it, okay? Right now, the stock market crashed. Well, if everybody had went to the banks and pulled out their money, well, we would have a much bigger problem than we have now. We're likely to enter a depression. There's tremendous job loss. Now the government is printing more money than they have, so we're likely to enter a depression, but it would be much, much worse if all of the banks closed and people were losing money just because they had it in a bank. So what this does is it helps ensure that you keep your money if you put it in the bank, okay? Now, there were some things, there's a stimulus package out there, right? And it's, well, where do we get the money from for a stimulus package? In 2008, you had big banks who, and we're talking about commercial banks. So like Goldman Sachs, for example, we're not talking about things like TD Bank, okay? Things like Goldman Sachs, banks like Goldman Sachs made investments that were bad, okay? And when your investments are bad, then you lose money. And places like Goldman Sachs now had no money, and if they have no money, then they go bankrupt and they close. So the stimulus package sort of rescued those big banks. And where does the government get money from? They get money from taxes on us, on the everyday person. So this was a big argument in the 2008 election, because you had two sides. One side was saying, why do we have to pay for the big banks' bad investments? And then you had another side that said, well, if we don't pay, then those banks are going to close, which means that our banks are going to close, which means that eventually we're going to lose money. So they said, we don't like paying, but we still have to bail out these banks. We don't have a choice. Now, the same thing is kind of true for this stimulus package, where you're saying it's not necessarily that we're raising taxes here because nobody has money, but what they're doing is they're kind of like printing more money. And where's this money eventually going to come from? Well, when the economy gets better, they're going to raise taxes eventually. But the question is, well, which is better? That we don't get a stimulus package at all, which is, that's everybody gets $1,200 and money goes to different states, all of these things about rearranging where money goes. Well, eventually we have to make up for it. We have to get that money back. And the way that we get it back is through taxes. But we could say, nope, we don't want to do that. And if we don't do that, then, we're in a deficit and our economy is going to stay, it's not going to improve. So these are things that we have to think about when we talk about the stimulus packages. And we don't really have a choice in this one. It's not a choice. There is no money, so we need to do something in order to rescue the economy. Okay, so these are some of the different things that we want to think about. Okay, now when we do this, we have very little in our bank accounts. We have very little interest. Okay, if you have a credit card, so for anybody who has a credit card, the interest. Sorry, hang on one second. Okay, sorry, I had to pause it for a minute. Okay, credit cards versus debit cards. This is the last thing that we're going to talk about. Okay, so we have a credit card. We have our debit cards. And each one has an advantage and a disadvantage. Okay, so a credit card is buy now, pay later. That's a big advantage. It builds your credit. So if you want to get another credit card, it's helpful if you have a credit card already.
Then you need to check out ours.
So a credit card builds your credit. Now, the very first credit card that you get is going to have a very, very little, I forget what you call it, a amount of credit that you can use, a balance. So you might only be able to buy $2,000 worth of worth of items at a time, okay? As you build your credit, that amount will increase. So it might be that after 5 years now you can buy up to 7,000. It might be after 10 years it could be an unlimited amount. It depends on the credit card company as well. So like for example, when I graduated from high school and I got my first credit card during my first year of college, I only had a $500 credit. That was just enough to buy books. The following year they increased my credit to $2,000 because I was paying my bill on time. Okay. So that's another advantage. Another advantage is if it's stolen, you can I don't want to say you can get the money back, but the money hasn't left your account yet. Okay. So these are big pros, and the reason why that's a big pro is that if somebody got a hold of your credit card number, what this means is that like for example, my credit card number was stolen and somebody bought 2 Keurig coffee pots. I don't know why they would do that, but they got 2 of them, and that was $400 worth. Now, I called the credit card company, and they said, okay, you didn't buy this, we'll take care of it. And I didn't have to pay for it, I didn't have to worry about it. It was stolen, they replaced my credit card, that was it. Okay? So, that's a huge thing. It builds credit if you want to buy a car. This helps you buy a car. The buy now, pay later gives you the chance to, okay, I want to buy this now, but my paycheck doesn't come for another 2 weeks. Well, this is helpful because you can buy it now, but you're going to pay the credit card bill after you get your paycheck. So this is an advantage, okay? But there are also huge disadvantages. The biggest disadvantage is that it has very high interest. And when we say high interest, I can mean it could be as much as 19%. Meaning if you bought something for $100 and you couldn't pay for it at the end of the month, okay? Well, now the next month, it doesn't cost you $100 anymore. Now it's costing you $120. And the next month, if you still couldn't pay for it, now it's like $144. It's more and more interest every single time. So it gets very, very expensive if you can't pay your credit card bills on time. Second thing that they have is late fees. And this kills your credit. So, for example, little personal information. These are the big cons. So, for example, I had one credit card. It was Capital One. Don't use Capital One. They're awful. You get a bill at the end of every month. So I don't do online checking because I worry about hacking. I worry about people having access to my information. So I get paper bills in the mail. So Capital One, I bought something for like $50. It was something I had to buy. I bought it for $50, and all of a sudden, I didn't get the bills, and I forgot about it. And I pay all of my bills on time. I pay them in full because I know about the high interest. So this never happened to me before, okay? But I never got the bill in the mail. And then the next month went by and I never got a bill. And I had just completely forgotten about this $50 charge. And then a month later, so now this is the third month, so 2 months of not paying, okay? 2 months of not paying. Now, all of a sudden, this $50 item is over $200. Over $200. That's because I was charged interest and I was charged $35 late fees for both months. So I called up the credit card company and I explained this to them. Capital One was my very first credit card, so I've been, they've had my business for like 20 years or something. And I called them and I told them this, and I said I never received the bill. So they said, okay, we're going to waive the late fees, we're going to waive the interest, pay the amount that you were supposed to pay, and we'll take care of it for you. So that's what I did. The next month, I get a bill. Now I'm charged another late fee with interest again. So I call the company up again and I say, okay, I don't understand this because I paid it. I paid it 2 days after I spoke to you. I mailed it in that day. You got it 2 days after I spoke to you. And there were some things that were my fault here. First thing that was my fault is I forgot that I used the credit card. I don't use that credit card a lot. And the second thing is when I paid the bill, I should have paid it right there over the phone versus mailing in a check. They said again, I called them up again. They said, okay, we'll waive the fee again. We'll waive the late fee. You don't owe anything. So I'm like, great. I look at my credit score. It's dropped 200 points from excellent to not good. And this is because of late fees. Now I've shown I'm unreliable. So I called up the credit card company. I said, no, this isn't fair. You killed my credit score with something. They had evidence that I never got the bill. They had looked it up, and the post office, it said return to sender. So they knew I never got the bill. It didn't matter. Destroyed my credit score. So this is a huge disadvantage of a credit card. Okay, one mistake can really cost you. Now, to be fair, I don't have a lot of other things to help improve my credit score, but this was still a huge problem. Okay, now debit card has other things that are advantages versus disadvantages. When you buy it, you pay for it. So it's buy now, pay now. Now, this could be a pro or it could be a con, right? It's a pro if you're the type of person who isn't going to pay your bill on time because you don't have to worry about interest, okay? So there's no interest. So this is a pro, okay? One is a pro. You don't have to worry about interest. You don't have to worry about it not being paid back. Okay. Another disadvantage is you might pay more than you have. Well, you're never gonna. It's not really a negative. You can't buy more than you have in your account, or you'll be charged a fee. And this is rare, right? Because once you're charged a fee, you're not going to do that anymore. So it'll be rejected. So that could be a pro. The biggest con is the money comes directly from your account. Now you may say, okay, well, if it's stolen, if your card is stolen, you still have a PIN number attached to it. So somebody would have to know your PIN number. Just if it's stolen. What if you go to a store and it didn't seem to go through, so they swipe it twice, and maybe it's a $50 item. Well, if they wipe it twice, then what they've done is they've essentially taken $50 out of your account twice. And now you're missing that $50. So if you call up a credit card, you've never paid the $50. You look at your credit card bill, you say, hey, I was charged twice, and you call up the credit card company or you call up the retailer, okay? Whereas with the debit card, you're already missing the $50. If you don't realize that you were charged extra, that money is now out of your account. It is much, much harder to get it back, okay? You have to call up the company that you bought from, or you have to call up the bank, and it is so difficult to get that money back. It can take months if you get it back at all. So that's a huge disadvantage of the debit card. So that's something that you want to pay attention to very carefully, okay? So this is how the economy works, okay? It's not the whole economy. This is not a big economy lesson. This is the basics of the things that affect you. So we're going to talk specifically about interest, okay? That's going to be the big thing that we're going to talk about right now. So there are some, we're going to talk about money in your account, okay? So let's start with, let's say, for example, you go into a bank with $1,000. And your account gives 10% interest each year. Okay, you would never get 10%. This is super, super high. I'm using it because it's a nice, easy number, and I want you to be really, I want this to be simple, okay, simple numbers. So you go into a bank with $1,000 and your account gives 10% interest per year. The way that this works is, let's say that you go in on January 1st, you put $1,000 into the account. January 1st the next year, it looks at what you have in the account and it says, okay, let's take 10% of that and add it to the $1,000, okay? So what we're saying is January 1st, 2020, let's say, you have $1,000 in your account, okay? Now we're gonna look at how much you have in your account on January 1st, 2021. Well, we're gonna take 10% of $1,000. And the way that we take 10% of $1,000 is we multiply by 0.10. So we're gonna do $1,000 plus 10% of $1,000. So this 0.10 times 1,000 is 10% of 1,000. Okay, and this is money that just gets added into your account. You didn't do anything to earn it other than put it into the bank. Okay, now what we're going to do here, and you're going to understand why we do this in a little bit, but if you notice, both terms have a 1,000 in common, so we're actually going to just factor that out. If we factor out the 1,000, then we get 1 plus 0.10. Okay. Well, if we take 1,000 and we multiply by 1 plus 0.10, that's going to give us how much we have in the account at the end of the year. And it tells us that we have $1,100 in the account. Okay. Now this 1 represents like 100%. This says take 100% of what we have and add 10% to that. Okay? So this tells us that on January 1st, 2021, we have $1,100. Now this is assuming we are not withdrawing or depositing. We're keeping this simple. Okay, now let's see how much we have on January 1st, 2022. Well, we can write this as $1,100 now. And then we're going to take 10% of 1,100. Okay, well what we can do is we can factor out 1,100, just like we did before, right? So here's the $1,100 that we had, and we're adding 10% of that. But we can factor it out. Here's the thing though, this 1,100 is equivalent to this, right? This we know is 1,100. So we can just do substitution. We're gonna replace 1,100 with this. And again, you'll see why in a second. If we do this, then what we get is instead 1,000 times 1 plus 0.10 times 1 plus 0.10 again. So we just substituted here. This that I'm boxing right now is $1,100, so it's the same thing, right? All we did is we replaced the 1,100 with this here. And the reason why we're doing that is you can see that we're taking the original amount and we're multiplying by 1 plus 0.10 twice. Now we have something exponential. So after the second year, we don't have to calculate this all the time. This is the same thing as 1 plus 0.10 squared. And you can see it's the same. 1,100 times 1 plus 0.10 is 1,210. But if instead we did 1,000 times 1 plus 0.10, sorry, I messed that up somewhere. And we're going to square that. Okay? Well, what does that equal? 1,210. It's the same thing. Okay? It's the same thing as doing 1,100 times 1 plus 0.10. Now we have $1,210. Okay, let's do this one more time for January 1st, 2023. So we already know that we could factor out a 1,210. Right? We're saying take $1,210 and add it to 10% of that. This 1 represents the 1,210. If we redistribute the 1,210 in, we have 1,210 plus 0.10 times 1,210. Okay? But this 1,210 is really the same as this right here. This is 1,210. So we're going to replace that 1,210 with 1,000 times 1 plus 0.10 times 1 plus 0.10 and then times the 1 plus 0.10 that we had before. So this part is 1,210. So times 1 plus 0.10. And what we're saying is that this is really 1,000 times 1 plus 0.10 to the third. And if we do that here, I keep doing the same thing. I keep forgetting to write times. This time we're going to raise it to the third power. The cube means raising it to the third, remember. And we get $1,331. And that would be the same as doing 1,210 times 1.1. Or 1 plus 0.1, which is 1.1. So you get the same thing. So what this means this would be after 1 year. This would be after 2 years. And this would be after 3 years. So if we want to know how much we have after 10 years, we don't have to figure out how much we have in the 9th year, right? If we had to figure out how much we had in the 9th year, then we would have trouble because we would have to do this 9 times over. We would have to know this. But what this is, hey, you only need to know what you had when you originally put the money in. So we know that after the 10th year, we have $1,000 times 1 plus 0.1, and we've been doing this 10 times now. And if we do that, we're going to raise this to the 10th. So on your calculators, you see this x to the y? That's an exponent. It's saying, okay, let's put in a caret, which represents exponent, and this is to the 10th. And this is saying, okay, so we have $2,593, and this is dollars and cents, so we round to the nearest hundredth. $0.74 after 10 years. So we've more than doubled our money, but remember, we have a huge interest rate here. And if we want to know, okay, well, how much do we have after 20 years? Well, again, we could figure this out. Just by doing 1,000 times 1 plus 0.10 to the 20. And if we do that, we're going to use this x to the y again. We get $6,727.50. So we're rounding to the nearest hundredth. Okay? So let's come up with a general formula. This is going to be our first formula. We have 3. Okay? So our first formula is P equals P0, 1 plus R to the T. Okay, let's define what this means. P0 is your original investment. Your APR. APR is annual percentage rate. So when we say 10% interest, we're saying APR of 10%. But our R has to be written as a decimal. Okay, when we plug in, we're plugging in 0.10. And then our T is time. This is almost always in years. Okay, and our P is what we have after T amount of time. So this is our first formula. Here's the thing though. This says that we give you the full 10% at the end of the year. But as a bank, we may not do that. We might actually break it up and give you instead half your interest in the middle of the year after 6 months, and then the other half after the next 6 months. Okay? So let's take that instance. So we don't usually say it like this. What we're really saying is you go into a bank to invest $1,000. With an APR of 10%, compounded semi-annually. So semi-annually is twice per year. Right? 6 months, every 6 months. Compounded is just a fancy way of saying collect interest. So you're getting 10% over the course of the year, but you're getting it twice. You're getting half of it after the first 6 months, half of it after the second 6 months. If we said compounded 4 times per year, it would be saying you're getting a quarter of it after the first 3 months, the second quarter after the next 3 months, the third quarter after the next 3 months, and finally the last quarter over the next 3 months. Okay, so that over the course of the year, you've gotten a total of 10%, but 2.5% each time. Okay, so the number of times that you compound is the number of times that you collect interest. So we're going to do the same type of thing, same amount of money, same annual percentage rate, but we're going to look at how much we have after a year in this case. So in this case, instead of after 1 year, we're going to do after 6 months. Okay, so after 6 months, we're going to get $1,000 plus $1,000 And this time, instead of multiplying by 0.10, we're only multiplying by 0.05. So this is your R divided by 2. Right? We're really only getting 5% here. We're taking the R and we're dividing by N because it's telling us that we're compounding semi-annually. So we're collecting twice per year. So each time we're only getting half. Okay? So the same way that we did it before, we can factor out the 1,000. And if we go and do that, this is 1,000 times 1.05. And we get $1,050 after 6 months. Okay, now let's see what we get after 1 year. Well, after 1 year, we're going to get the 1050, which is the 1,000 times 1 plus 0.05. So we have 1,050 plus 1,050 times 0.05. Now we already know what's going to happen here. We can factor out the 1,050. And we know that the 1,050 is equivalent to this here. This is what's allowing us to use the exponents. So we're going to plug in. What that means is that we could figure this out just using the 1,050. We just substituted. This was the 1,050. So this is really, I'm breaking this up for you a lot here, just so that you see where this is all coming from. $1.05 squared. And if we do that, what this is saying is after 1 year, one plus 0.05 is 1.05. Well, now we have $1,102.50. Well, this is more than we had before. We only had $1,100. Here we have more.
Everything that I wanted as a child, I got.
So we have more here. So that's actually a huge thing. The second 6 months, we're collecting 5% on $1,050. So we're collecting extra that we didn't have before. In the other case, it would be as if we collected 5% on 1,000 and then 5% on 1,000 again. Here we're not. We're collecting 5% on 1,000 in the beginning, but then we're collecting the second 5%, not on 1,000, but on 1,050. Okay? So this is because collecting interest on interest. So the question is, why would the bank do this? And the bank actually does do this. It gives you interest more often. So here's why the bank does this. Now, if you don't withdraw at all throughout the year, then you get more money, okay? Because you're collecting interest on interest. But let's say, for instance, that you start off with $1,000 and then you withdraw $500 in June, and then you put it back in December. Well, when the bank gives you money after a year, okay, it only looks at what you have on December 31st, okay? It doesn't look at what's happened in your account up until then. So the fact that you withdrew the $500 and you only had $500 in your account for half the year, it doesn't matter, okay? Because you're still going to collect that amount of money. You're still going to collect interest on the full $1,000 because that's what you had at the very end. If it collects more times per year, if you don't withdraw any money, then it's a benefit to you. But if you do, let's say that you have $1,000 and in March you withdraw $500, and then you redeposit that $500 in November. Well, if it collected once per year, it's giving you the full 10% on $1,000. But if you're collecting interest twice, well, you withdrew $500 in March. So that means on June 1st, when the bank gives you interest, they're only giving you interest on $500. They don't have to give you your 5% on $1,000. They're giving you 5% on what you have. So now you're actually getting less because you're only getting 5% on $500. So it's a benefit to them if you're withdrawing. It's a benefit to you if you're depositing, okay? Or if you're not touching your money. So the way that the bank feels is it makes you feel better if they give you interest more often, because it's going to make you feel like you're collecting interest on interest. And for the people who are kind of depositing versus withdrawing, it balances out. It all balances out throughout the year, okay? Because some years you're going to deposit, some years you're going to withdraw. So it's kind of a psychological thing. It says it makes you feel like you're getting more money, but for them, it all balances out in the end. Okay, so now we have a second formula, and the second formula has to do with whether or not it's compounding, whether or not you're collecting more interest. So let's write down our next formula. So it's very similar. And this one is P equals P0, right? We have our principal. The P0 is the original investment. I'll put this in up here too. It's also, we can call it the principal amount. That's the original amount that it is. So we have P0, and then instead of 1 plus R, every time that we do this, we're doing 1 plus R, and we're dividing by the number of times that we compound. So if we're compounding twice, then we're going to take our APR and we're going to divide by 2. If we're compounding 4 times, we're going to take our APR and we're going to divide by 4. If we're compounding 10 times, we're going to divide our APR by 10, okay? And then instead of just multiplying by T, we're going to actually take T and we're going to multiply it by N. So our exponent isn't just T, it's NT, okay? And it's NT because you can see that at the end of the year, you've collected interest twice. At the end of 2 years, you will have collected interest 4 times because you're doing it 2 times per year. At the end of 10 years, you're collecting it 20 times because each year you're collecting it twice. So you would multiply the number of years by 2. Okay, so let's write this down, what each thing represents, just like before. So this original investment, I'm going to add it up here too. It's referred to the principal amount. So P0 is the same thing. Principal amount or original investment. I switched this, that's because it means the same thing. Your R is still your APR as a decimal. Typical mistake is that people don't plug it in as a decimal. Okay, you're gonna know that it's a mistake because your final number would be huge. If you plugged in 5 instead of 0.05, this number would probably be in the 100,000s, which wouldn't make any sense at all. Okay, and your N is the number of times you compound per year. Which means R over N is the amount of interest you get each time you compound. Now you don't actually have to remember both formulas, because in this formula, what we're doing is we're saying you're compounding once per year. Well, if N is equal to 1, R over N is just R. And if N is equal to 1 here, 1 times T is just equal to T. So this formula includes this one, okay? So just a couple of things. Just in terms of terminology. Compounding semi-annually just means that N is 2. If you see that it's compounding quarterly, then your N is equal to 4. If it's saying it's compounding monthly, then you know that your N is equal to 12. If it says weekly, your N is equal to 52. And if it says daily, then you would use 365. Okay. So we have one more formula. And that last formula is if you compound continuously. So compounding continuously means that you're compounding an infinite number of times, which again, for the bank is good because it kind of balances everything out, okay? So if you compound continuously, you're compounding an infinite number of times per year. Which means you need a new formula. You can't use the formula that you had. Because you can't plug in infinity into that formula. Derive that formula, okay? And the way that we're going to derive it is we're going to take out the interest rate, we're going to take out the N, and we're going to take out the T, and we're just going to look at a small part of the formula, okay? And this is our last formula. Look at this 1 plus 1 over N to the N, okay? So we're going to create a table. And we're just going to plug in different values for N. So if we plug in 1 for N, and we plug that in over here. 1 over 1 is 1. So 1 plus 1 is 2, and 2 to the first is 2. So we get 2. If we then plug in a larger number, okay, so remember, n is infinity. N is a huge number, so that's what we're doing. We're plugging in a huge number. So if we plug in 1,000, we actually get 2.716923932. Now we're going to plug in an even bigger number. We're going to plug in 10,000. And what we get here is 2.718145927. Now we're going to plug in 1,000,000. And if we plug in 1,000,000, we get 2.718280469. If we plug in 1 billion, that was not 1,000,000. I got it overexcited there. That's 1,000,000. If we plug in 1 billion, we also get 2.718280469. So notice what's happening. As we plug in larger and larger numbers, this becomes the same. This approaches the same number. This is because this gets really, really, really tiny. So 1 plus this, it's not making much of a difference. 1 plus a really, really tiny number isn't that different from 1 plus a really, really, really tiny number. So what's happening is we approach a special number. Some of you have heard of this number. It's E. And E is 2.718280469. And E is on your calculator, okay? Sorry, I said 2.7188. I should change this. Two 8 1 8 2 8 and so forth. Okay, it's an irrational number. It's like pi. It has a value. If you remember, we said E is not a variable that we typically use. Okay, and this is why, because E has a value. So this means that we have one last formula. And you only use this formula when it says compounding continuously. This time, 1 plus 1 over n to the n becomes E, and the r actually moves into the exponent. So now we have essentially two formulas, because remember, we don't have to use this formula here. We're really only using this one when n is equal to 1. That's what this is. So I can even add in here annually n is equal to 1. And then we're using two formulas, okay? Okay, so let's just do a couple of examples and then we're done with this for today. So let's say, for example, you invest $23,000 with an APR of 2%, compounded 3 times per year. And the question would be, how much do you have after a certain number of years? So let's say, how much do you have after 7 years? Okay. Well, this is a plug and chug, okay? It's not compounded continuously, which means you're not going to use the formula that we just did. You're going to use the other formula. You're using this one, P0 equals 1 plus R over N to the NT. Your R is 0.02. Remember, it's as a decimal. Your P0 is 23,000, because that's your original amount. Your N is 3. It's compounding 3 times per year. And your T is 7. So this is a plug and chug. You're just plugging it in here. So your P is 23,000 times 1 plus 0.02 divided by 3. Every time you get interest, you're getting a 1/3 of 2%. And then it's 3 times 7. Over 7 years, you're collecting interest 21 times. So let's go to our calculator. Now do this slowly. I'm going to do it, and then you're going to do it in the same way. So you're going to do 0.02 divided by 3 first. This gives you this number. It should be a small decimal. You're going to add it to the 1. The 1 represents 100% of what you have. Okay, so now you have 1.0067. You are going to raise this to the 21st power. So you're doing this order of operations. Parentheses first. Inside the parentheses, we have division. Division comes first. Then you add. Then exponents after parentheses. So we raised it to the 21st power. That's 3 times 7. And now we're multiplying by the 23,000. And this tells us that we have 26,444. And it's dollars and cents. So you round to the nearest hundredth. Okay? You will always round to the nearest hundredths. And that's it. It's a plug and chug. Let's take another one. Suppose you invest $8,000 with an APR of 0.5%. Compounded continuously. So notice you don't have an N here. You want to know how much you have after 10 years. Okay, so in this one, it's compounded continuously. As soon as you see these words, you're using that second formula. You're using the one with E. And here your R is 0.005. It's as a decimal, so you move it, you divide by 100. Okay? You're moving your decimal point two places to the left. Your T here, you want to know how much you have after 10 years. And your P0 is 8,000. So now we just plug in. It's a plug and chug. You just have to figure out which formula to use. Compounded continuously says you use the formula with E. Compounded any other amount, so here it's not compounded continuously. Any other case, you're using this formula, okay? So here, we're doing P equals 8,000 times E to the 0.005 times 10. Make sure you plug it in as a decimal. So you're going to do order of operations, okay? You have to first figure out what your exponent is. So 0.005 times 10 is 0.05. Now you're going to do E raised to that power. So here's your E. You're raising it to the 0.05. Now you multiply that by your 8,000. And notice you don't make that much money, okay? You're not going to make that much money. It's a very small, I mean, $400 is nothing to sneeze about, but it's not as much money as in some of these other problems that we've done. Okay. So it's $8,410.17. Do dollars and cents, okay? Let's do another one. We'll do two more, just so that you make sure that you got the hang of it. At this point, you should pause the video and do it on your own. So I'm going to leave out some of these words. You invest $12,000. Your APR is equal to 0.25%, compounded monthly. How much? After 16 years. So this is a place where you might want to pause the video, do it on your own first, and then start the video again and see how we work through it. So this doesn't say compounded continuously, which means that we're using this equation up here. So our R is 0.0025. Remember to divide by 100. Our N is monthly, so our N is 12. Our T is 16. Because we want to know how much we have after 16 years. And our P0 is 12,000. So again, it's a plug and chug. We're doing 12,000 times 1 plus 0.0025 over 12 to the 12 times 16. So now we go to our calculator. We're going to do 12. We're going to do parentheses first. 0.0025 divided by 12. Then we're going to take that and add it to 1. Now we're going to raise that to the power of 12 times 16. So you have to put the 12 times 16 in parentheses. Otherwise, it's just going to raise it to the 12th first, and then it'll multiply by 16. So this 12 times 16 has to go in parentheses. And then notice you just get a number a little bit above 1. That's the way it should be, okay? If you got something much above 1, then you did something wrong. And then we're going to multiply by 12,000. And it makes sense that we wouldn't get such a high number because our interest rate is so low. So it's $12,489.68. Okay, and finally, last one. So you invest, let's say $25,000 with an APR of 3%. Maybe you have a CD. CDs can go as high as 3%. Compound it continuously. You want to know how much after 8 years, say? Okay, again, consider pausing the video. So in this case, we see compounded continuously. That's the word that will be used. So we're going to be using P equals P0 e to the RT. Our R is 0.03. Our T here is 8. And our P0 is 25,000. So we just plug and chug. P is 25,000. E to the 0.03 times 8. So we're going to do the 0.03 times 8 first, so that we know what the exponent is. You can do E and then to the power of, and then put the 0.03 times 8 in parentheses. That would be fine too. So actually, if we did that, it would look like this. E to the power of, in parentheses, 0.03 times 8. Okay, and you see the 0.24, that's telling you what the 0.03 times 8 is. And we get a number that's above 1. Okay, it's not much above 1, it's a little bit above 1. And we multiply by 25,000. And we get 31,000, so it's a higher interest rate, which is why we have a higher amount. $31,781.20. I wrote 28, but I meant 23. Just to give you an idea, so don't write this down if you're doing any writing. If we did E to the power of, and instead of doing 0.03, we did 3 times 8, this is the difference. You see how we get this huge, huge number? It's not just a little bit above 1. It's like 26 billion, okay? And then we multiply by our 25,000. This doesn't make sense that we get 3% interest and we're doing this. What this is telling us is that we're getting 30% interest. Even if you did E to the power of 0.3 times 8. Even here you get a number 11. You should just get a number above 1. Okay, if the interest is really high, maybe it'll be a number above 2, but it certainly won't be as high as 11. Okay, and you can see that even if you multiply this by 25,000, you get this huge number. There's no way that you're going to have 275,000. So at the end, just make sure that your answer is reasonable. Okay, so just small notes. Just to finish us off, I know that this is a very long video, so just to finish this off. If, let's say, where it's really one note that I'm going to leave you on. APR is the annual percentage interest, right? But the APR in this case is 10%, but we're actually getting a little bit more than 10%, right? We're actually getting 10.25%, I think it is. So we're actually getting a little bit more. That we refer to as the APY. So the APY is the annual percentage yield, and it's the actual interest that we get, including the amount of times that we compound. Okay, taking that into consideration. So I'm going to put this here just as an extra note. Just because when you go into a bank and you get their brochures or you look on their websites, sometimes instead of seeing APR, you'll see APY. And I just want you to understand that it's the actual interest that you're getting, taking into account the number of times that it's compounding. Most of the time, the interest rate is so low that the APY and the APR is actually the same. But the APY otherwise will always be higher than the APR, okay? Because you're always getting a little bit more if you're compounding more times per year. And then it's probably worth mentioning that if you're talking about things like half-life, it's a little bit different. Your half-life, you would be taking your original amount and you would be multiplying by 1/2 instead of E, because every day it decreases by 1/2. So that's probably worth just mentioning. But we're not actually going to be looking at that so much. So I'm not going to write it down or even do any problems with it. But this is essentially what you need to know and what you need to be able to do. This is it for exponents. Our next thing is going to be logarithms. So there will be 2, maybe 3 videos on logarithms. I know this one is really, really long. So if I won't make another one that's this long. And then you'll have your quiz. Great.